All right, in this video, I'm gonna do a little bit more with polygons, and we're gonna find the area of some of these polygons, but more specifically, we're gonna be using some vocab words that will be on the theorem sheet. You hopefully know the radius. This word apothem is something that we'll need to make sure that we feel good about. That's the distance from the center to any side of a regular polygon, and kind of one of the key things with the apothem is that when you draw it to the side, it's going to intersect perpendicularly. So you'll see that right angle, okay? So basically what we've proved in one of our CLTs is that the area of a regular polygon is equal to 1/2 times the apothem times the perimeter. All right, so we're gonna be using that area formula when we have a regular polygon. All right, so a lot of these I've already done. As you can take a look at Canvas for the key. I'm gonna do just 4 because there's a lot of work to do. Bringing with stuff that we've done in previous units. So I'm only gonna do 4, but it will be still a pretty lengthy video. All right, so we're gonna do 4 first. Okay, so we have a regular triangle, and we're told that the perimeter is 24 times the square root of 3. So if the perimeter is 24 times the square root of 3, if I take that perimeter and divide it by 3, so 24 root 3 divided by 3, I can find my side length. So my side length is going to be equal to 8 root 3. All right, so that is 8 root 3. Now you'll notice this apothem, which is drawn from the center of the triangle to intersect perpendicularly, right? Make that right angle. And it's also going to take this 8 root 3 and cut it in half. So this is going to be 4 root 3. Now, because this is a regular triangle, that means that the sides are equilateral and all the angles are the same. So it's equiangular. So we have 60 degrees, 60 degrees, and then you can see this is being split. So if we split that 60 in half, we get 30 degrees. So this is actually a 30, 60, 90 right triangle. So we're going to be using that information from a couple units ago to help us find the apothem and the radius. Okay, so if we know the leg that is across from the 60-degree angle, we can find the short leg across from the 30-degree angle by dividing by root 3. So I'm going to do 4 root 3 divided by root 3. And that is going to give me just 4. So the short leg is going to be 4. In this case, that's the apothem. So the apothem is equal to 4. Okay, now if we know the short leg is 4, we can get from the short leg to the radius or the hypotenuse by doubling it. So that radius is going to be equal to 8. All right, so I'm going to write down the radius is 8 units. Okay, so we found the side length, we found the apothem, we found radius. So now we're going to find area using that new formula that we haven't used yet, 1/2 times the product of the apothem times the perimeter. So I know both of those things. I know the apothem we just found was 4, and the perimeter is actually given to us at the beginning of the problem. That's 24 times the square root of 3. Oop, I'm sorry, it's not a fraction. My bad. 24 times the square root of 3. So when I go ahead and find the area here, all right, we're going to leave it as a radical. So half of 4 is 2, and then 2 times 24 is 48 times the square root of 3 units squared. All right, so that is using a lot of stuff from different units and stuff that's new with that area formula using the apothem and the perimeter to find all those pieces of information. Okay, let's keep going. Let's do number 5. All right, this time we have a regular hexagon, and they're telling us that the side length is 4 centimeters. So this is going to be 4 centimeters. So that means if I look at this apothem that's drawn, that's going to split that side in half. So this is going to be 2 centimeters. Okay. Now, if you think back to the work we did a couple videos ago with the CLT as well, to find the measure of each of these angles, let's first find the sum of the interior angles using a theorem from before. That's equal to n minus 2 times 180 degrees. So in this case, that's 6 minus 2 times 180. So that's 4 times 180, which is going to be 720 degrees. So to find a single angle, we're going to take the 720 degrees and divide it by the number of angles, because they're all the same, right? The regular hexagon means the angles are all the same. So divided by 6 would say that each angle is 120 degrees. Now, the reason that's important is because if you see this radius that is drawn, it is splitting that 120 degrees in half. So this is actually going to be 60 degrees down here, which means that this right triangle has a 30-degree angle there. So we're back to that 30, 60, 90 work that we've done in the past. This time we have that side is a small leg across from the 30 degrees is 2 centimeters. So the apothem, the small leg is 2. The larger leg is 2 root 3. There we go, finally. And then the radius or the hypotenuse is you double the small leg, so that's 4 centimeters. Okay, whew. All right, now let's find the rest of the stuff. So we just found the apothem, right? The apothem is equal to, what did we say it was? 2 root 3 centimeters. And then the perimeter, we're going to find if there's 6 sides and all the sides are 4, so 4 times 6 is going to give us, I guess I'll make this look nicer. All the sides are 4 centimeters. There are 6 of them. There we go. So 24 centimeters. And then the radius we just found, the radius is 4 centimeters. All right. And one thing that if we haven't proved already in class, we can prove it in class. The radius and the side length in a regular hexagon are always going to be the same. All right, you can make the 6 equilateral triangles in all these hexagons if you wanted. Anyway, just something to remember. And then finally, let's find the area using our new formula, 1/2 times the apothem times the perimeter. So that's 1/2 times the apothem, which is 2 root 3, times the perimeter, which was 24. So our area is going to be equal to, I'm going to do half of 24, which is 12, and 12 times 2 gives me 24 root 3 centimeters squared. All right, so that is it for the regular hexagon. Let's do 2 more. We're going to do 7 and 8, all right, using 2 different shapes. The next one up is a regular pentagon. I went ahead and did my best to draw it. Obviously, it's not my best drawing, but again, all the sides are the same, all the angles are the same, and they're telling us that the apothem, which I drew here, is 13 centimeters. All right, now I'm going to use my understanding from the sum of the interior angles to find the measure of each individual one. So in this case, that's going to be 5 minus 2 times 180, right, which is 3 times 180, which is 540. So the sum of these 5 angles inside is 540. But then I want to take that 540 and divide by 5, since I have 5 angles, which is going to give me 108 degrees. Okay, 5 goes into 5 once, 5 goes into 48 times, so 108 degrees. All right, that means each of these angles is 108, which also means in this right triangle, I'm splitting that 108 in half to get 54 degrees. All right, if you wanted to write the other one, 90 minus 54 would give you that 36 degrees. But what you should notice is, different from the previous ones we just did, I didn't get a special triangle. All right, I didn't get a 30, 60, 90 right triangle. I didn't get a 45, 45, 90 right triangle. So if I want to figure out all this other stuff, right, like I want to figure out the radius, I want to figure out the side length, I need to figure out some way to find another side of this right triangle, and that is with trigonometry. So I'm actually going to use, all right, I'm going to use tangent, all right, so I can find this half of the side down here. I'll call it x. All right, so I'm going to say tangent of 54 degrees equals 13 over x. All right, doing my math that we did a couple units ago, I'm going to move the x over with multiplication and then divide the tangent over with division to get x equals 13 over the tangent of 54 degrees. Line that up real quick. There we go. Okay, so let's get, right now, I'm not going to get an approximate answer. I know it says to round at the end, but I want to wait till my rounding until I'm all done. So what I'm going to do is I'm going to say that the side length, right, if you look at my figure, but I just found x in terms of tangent. So my side length is going to be twice that. So I'm going to say the side length is 26 over the tangent of 54 degrees. So what my brain is doing is I'm taking that 13 and multiplying by 2. So to find the area of this, using my formula, which is area equals 1/2 times the apothem times the perimeter, I need to first find the perimeter. All right, my perimeter is equal to my side, which I have right there as a fraction, and there's 5 of them. So I'm going to do 5 times 26 over the tangent of 54 degrees. That's the perimeter. So here's my area, exact answer. 1/2 times the apothem of 13 times 5 times, take away some of these little dots here, times 26 over the tangent of 54 degrees. So I'm going to be typing that in to my Desmos calculator. And again, we'll talk about this a lot in class. But the idea here is you should not be rounding until you're done, right? So I'm going to type all this in and then I will round. Do not get a value for x and then double it because you'll just be using a rounded number. Do not use rounded numbers while you're doing your math. Wait till the end. Okay, so here we go. Let's type it in. So I've got 1/2. All right, so 1/2. And then times, I believe it was 13. Let me check real quick. 13, yes. And then 5. And then times 5. Oop, not 55. And then times, and then this is going to be, I think it was 26 over the tangent of 54 degrees. Don't look at the answer yet because I do have to change this into degrees. Let me just confirm I got the right stuff. So was that 26 over? Yes. Okay, so that's not the answer. I got to change this to degrees. There we go. That is the answer. So approximately, let me get my rounding here, to the nearest hundredth. So rounding to the nearest hundredth is 613.93. 613.93. 613.93, and that's square centimeters. All right. I love this problem for many reasons, but probably the most important reason that I find it really interesting is because we had to use trigonometry to find ultimately the side length, right? We found half of it, and then we doubled it to find the side length. So, and it also requires you to feel comfortable writing equations, or sorry, I should say plugging in values into formulas that are not numbers, right? 26 over tangent of 54 degrees. That is a number, but we wait until the very end before we actually, round, okay? All right, one more, number 8, and then we'll be done. All right, I want to do one with a square. All right, so if this is a square, these are all 90 degrees, and then you probably can figure out if that's going to split it in half, that's 45. So then this one's also 45 degrees for this right triangle. It tells us that the apothem is 5 root 2, and we're trying to find everything that's going on here. Now, if this is a 45, 90 right triangle, then this over here is also 5 root 2. So my side length is going to be double that, right? So this one over here would be 5 root 2. So 5 root 2 plus 5 root 2, my side length is going to be 10 root 2. And that's feet. Now I can find the radius using my understanding of the 45, 90, right? We take our sides, our legs, and we multiply by root 2 to get the radius. So the radius is going to be 5 root 2 times root 2. And when you do that, you actually end up getting 5 times just a 2, right? Root 2 times root 2 is just 2. So our radius is going to be 10, and that's feet. Okay, next thing is the perimeter. All right, for the perimeter, the side length is 10 root 2, and there's 4 of them. So 4 times 10 root 2 will give us the perimeter, which is 40 root 2 feet. And finally, the area, using our new formula, 1/2 times the apothem times the perimeter. I'm going to plug in my apothem, which was 5 times the square root of 2. And the perimeter I just found was 40 times the square root of 2. Okay, this one, what I'm going to do first is half of 40 is 20, right? So my work up here, I've got 20 root 2 times 5 root 2. Now the 20 times the 5 is going to be 100. And then the root 2 times root 2 is just 2. So our area is going to be 200 square feet. All right. Okay, so I know I skipped a bunch here. Again, there's a lot going on. Check out all the other questions, the key on Canvas, and come see us if you have any questions. You know that we really like questions like number 7, number 8. We're using different type of triangles within it. And it'll just take some time to get used to using this new area formula. But I think you'll get it, and come see us in office hours with any questions. Good luck.